Hello students. So as we are discussing about exponent from last two videos, this is a third video of that exponent sequence, and in this video we discuss about zero and negative exponent. We already discussed this one, but once again under the heading of zero and negative exponents I am going to discuss with you and clarify you what are zero and negative exponents. So let's start. Suppose in case of division, if we are dividing a to the power b by a to the power b, same term with same exponential power, we are dividing, what we obtained as per rule, we know that power must be subtracted in case of same base. Clear? Here we have same base, so power b minus b, and as we know that a to the power b minus b is equals to a to the power 0. This is known as your exponent power. This is known as your zero power or zero exponent, and this one is equals to, this is value is always equals to 1. Why it's 1? Because we know that a to the this complete term divided by this complete term gives you the unique result, that is your 1. So this is equals to 1, or we may write over this over here, 1 equals to a to the power 0 likewise. So from this we can say that a to the power 0 equals to 1. This is your zero exponent. Now next one is your negative exponent. Now what about negative exponent? Suppose if any power is in negative form, like a to the power minus b. So to convert this negative power to positive power, we can reciprocate the given exponential term. What is the meaning of reciprocate? We divide this 1 divided by this, or in simple we can write down a 1 upon a to the power b. Here you can see negative power changes to positive power, but this complete exponential term moves from numerator to denominator. Similarly, if we have 1 upon a to the power minus b, then to convert this negative power to positive power, we reciprocate the complete term and we have a to the power b. Here again you can see a negative power or negative exponential term is at a denominator, but when we try to convert this negative power to positive power, this denominator terms moves to the numerator term. So this is the concept of negative exponents. Hope this one is clear to you. Move to the next part. We discuss some question answers. Now if we try to understand by using some numerical expressions, question says that what is the value of 419 to the power 0? What is the value of this number? So in this case, as we know that something to the power 0, so here something to the power 0 equals to 1, so we can say this one is equals to 1. This is the first. What about negative exponent? Suppose it is given to you 7 to the power minus 2. So what does it means? It means 1 upon 7 to the power 2. Further we can say it's a 1 upon 49. Clear? One more example we can discuss. Suppose it is given to you 1 upon 3 whole to the power minus 1. See, Here base, in this case base is 7 only, so we can reciprocate this one to denominator to get the positive power. In this case this is the complete one, this is the first, and this is the negative power. So in this case we can say 1 upon 3 whole to the power plus 1. In place of minus 1 we can say plus 1. So what we have? We have 1 upon whole 1 upon 3. Ultimately this 3 moves to the numerator part, as we know. Because why it's moved to the numerator part? Likewise, because I'm explaining this portion why this becomes this one. See, it's a 1 divided by 1 upon 3. 1 divided by 1 upon 3, and this changes to multiply sign by reciprocating the second term. So 1 into 3 equals to 3. So this, why this equals to this, I think you can easily understand. This is your understanding part. This is need not to copy this part, but you must know that 1 upon 3 is equals to 3. Hope this one is clear to you. Move to the next part. Let's discuss some more negative exponents. In this case we have 2 upon 3 whole to the power minus 1. Here we know that we can easily reciprocate, or simply we follow the rule. Clear? Here we can write down 1 upon 2 up 1 whole 2 upon 3, or we can write down over here 3 upon 2. Hope now you can easily understand why this equals to 3 upon 2. This 3 moves to the numerator part to remain at this place. It's a 3 upon 2. Now next is your, suppose it's a minus 3 whole to the power minus 1. So how we can write 1 upon the complete minus 3 part moves to the power 1. So ultimately what we have? 1 upon minus 3, or we can say minus 1 upon 3. So hope this one is clear to you. Move to the next question of same type. It's a minus 1 upon 2 whole to the power minus 1. It's a minus 1 upon 2 whole to the power minus 1. How we convert this one? It's very easy. First we change the sign of the power. How we change? It's a 1 upon minus 1 upon 2 whole to the power 1. Ultimately what we have? 1 whole minus 1 upon 2. We can say that it's a minus 2 upon 1, that is your minus 2. So hope this one is clear to you. Move to the next part. Now we are going to solve some more questions about zero exponent. Here it is 20 to the power 0 minus 23 to the power 0 whole to the power whole multiplied by 18 to the power 0. So this is your question. How we solve this one? First we change the that zero exponent to the value. It's a 20 something to the power 0 equals to 1 minus something to the power 0 equals to 1. 1 minus 1 into 1. We change the bracket. So 1 minus 1, it's a 0 into 1, it's a 0. Hope this one is clear to you. Move to the next question of this type. Next question says that 3 to the power minus 1 divided by 4 to the power minus 1 whole to the power 2. This is one of the question, and question says that so find out the value. How we find the value? See this side here. First we change the power of, change the sign of the power. So it's a 1 upon 3 divided by 1 upon 4 whole to the power 2. Hope this one is clear. Now change the divide sign to multiplied sign. It's a 4 upon 1 whole to the power 2. Ultimately what we have, 4 upon 2, 4 upon 3 whole to the power 2. Clear? I am solving this side. From here it's a 4 is, we can say 4 square upon 3 square, or we can say 16 upon 9. This is your solution. In this type of question, first we try to change the power from negative to positive. If it is already positive, then we perform the operation within the bracket, what operation given. Then we change the power. If already negative given, then change the to positive one, or already positive given, then simplify likewise. This is a type of solution. Hope you can easily understand this type of question. Move to the next type of question. This is a simplification type question. We have to simplify the complete expression. So see, there are various types of negative and zero exponents. We try to simplify. First we convert all the negative power to positive power. Here we can change 4 upon 9 whole to the power 2 into 1 upon 4 whole to the power 2 into, here we can easily reciprocate 3 to the power 2 into, here whole to the power is 0, so either we can write 17 to the power 0 upon 18 to the power 0, or directly we can write down 1. Now next line we change it 1 upon 16 upon 81 into 1 upon 16 into 9. Now if we try, it's 81 upon 16 into 16 upon 1 into 9. Hope this is visible to you. Yes. Now see, in this case we can easily cancel 16 and 16. Why? One is denominator, while other is a numerator. In between them there is a multiply sign. So come to this side. Here we can write 81 into 9. Here either you can multiply or write down 7 to 9, or you can see it's 9 to the power 2, here 9 to the power 1. We can write down this as 9 to the power 3. In place of either you can write this one, or in place of this you can write 19 to the power 2 into 9 to the power 2 into 9. Here if you see, 2 base is same, power is 2, and here power is 1, so we can add. So either you can write up to here, or you can move to this part. Both way is correct. Hope this one is clear to you. You can simplify some more problem given in your book. Now we are going to discuss some more questions. Here it is -3 whole to the power -6 divided by, again -3 whole to the power -3. We have to simplify. This type of question may you encounter or may come, you people come to simplify this type of question having given some base with different negative power with operation same base with negative power. Sometimes this, either this power is negative or this power is positive, or sometimes this power is negative or this power is positive. Whatever it is given, you have to follow the observation. What is the meaning of observation here? First we change the negative power to positive power. As you know, it's a minus 3 whole to the power 6 divided by, sorry, 1 upon minus 3 whole to the power 3. First we change the sign of the power, then we perform the operation minus 3 whole to the power 6 multiplied by, here second term reciprocate, so minus 3 whole to the power 3. Now by laws of exponent we can say that minus 3 whole to the power 3, this power raised to upward with negative sign, so ultimately what we have minus 3 whole to the power minus 3. This one is clear to you, I think. Now move to the next line. Here we can say that 1 upon minus 3 whole to the power 3, or 1 upon negative power with odd, negative base with odd power. Answer is negative 3 to the power 3, it's 27. Ultimately we can write down 1 upon 27. So likewise you have to solve all the other question given in question 5 or 6 or whatever it is. You must check your book. Move to the next type of question. Here you can see another type of problem. Here if you start from the smallest bracket, minus 3 upon 4 whole to the power minus 2 whole to the power minus 3 whole to the power minus 1, they are different power with different bracket. So in this type of question we try to remove out bigger bracket to smaller bracket, not move to the smaller to bigger. So here we can write down, we can move to the square bracket, whatever it is, minus 3 into minus 1, it's a plus 3. So hope, so see here. Now next if we move minus 3 upon 4 minus 2 into 3, it's plus 3, it's a minus 6. Now we change the negative power, it's a 1 upon minus 3 upon 4 whole to the power 6. Ultimately what we can write over here, we can just reciprocate minus 3, here we can write down 4 whole to the power 6. Remember in this case, as we know, numerator moves to the denominator part, but we have to move power also, so this complete power reciprocate inside, or no, okay, this one is easier for you. Now we can say 4 to the power 6 minus 3 whole to the power 6. 4 to the power 6 means what? It's a 4 into 4 into the 6 times 4. So let's start. It's a 4 into 4 into 4 into 4 into 4 into 4. Since power is even, base is negative, so answer is positive. How we find such type of long multiplication? See here. Here 4 4s are 16, 16 4s are 64, and again 64 into 64. There are two pair, so we use our common sense. 64 into 64, 4 4s are 16, sorry, 4 4s are 16, 1 carry, 4 6 are 24, 1 5, 2 5 6, 6 4s are 24, 2 carry, 6 6 are 36, 36 plus 2 38. What is this? 6904096. So here we can write down 4096. Now in case of 3, see, 3 3s are 9, 9 3s are 27, 27 3s are 81, 81 3s are 243, 243 3s are, so 2 in mind we can multiply 243 multiplied by 3, it's a 3 3s are 9, 3 4s are 12, 3 2 are 6, 7 7 2 9. So this is our solution. Hope this one is clear to you. Move to the next question. In this question it says that if x equals to this value, then find out the reciprocal of x. So first we simplify this complete value of x for x, then we solve further. So it's a x equals to, here we start to solve 2 upon 3, 2 and 3, so whole to the power 6. Here negative power is there, so it's a reciprocate 2. Here again reciprocal is there, 1 upon 3 to the power 1. Here we can say 1 upon 2 into 3. For 6 it's a 2 into 3. Now here we can write 2 to the power 6 upon 3 to the power 6 into 3 to the power 2 into 1 upon 3 into 1 upon 2 into 3. Now if we try to solve by using laws of exponent, we can say 2 to the power 6, above there is no 2, here only 1 2, minus 1 into 3 to the power 2 minus 3 to the power 6 minus 1 minus 1. For this it's a minus 1, and for this it's a minus 1. So this is the arrangement, or we can say it's a 2 to the power 5 into 3 to the power 2 minus 8. Come to this side, it's a 2 to the power 5, it's not look like 5, it's look like s, 5 into 3 to the power minus 6, or we can write down 2 to the power 5 upon 3 to the power 6. This is the value of x. Little bit mistake is there. We can write down x equals to, no, we can write down x equals to. So this is the value of x, but question says that find out the reciprocal of x, means therefore 1 upon x equals to, we can change 3 to the power 6 by 2 to the power 5. If you people wish, you can simplify this one and get the answer reciprocal of 1 upon reciprocal of x. So move to the next type of question. See, next type of simplification type question. Here if you see, this base and this base is just reciprocal to each other. So how we simplify? First we convert the powers, 8 upon 11 whole to the power minus 10 into 11 upon 8 whole to the power minus 12. In this type of condition, we change only one power to positive. So here you can easily write down 11 upon 8 whole to the power, from minus 10 it's converted to plus 10. Why? Because we reciprocate the inner part. 11 upon 8 whole to the power minus 12. So we can say 11 upon 8 base is same, 10 plus within bracket it's a minus. So ultimately what we can write down over here, it's a 11 upon 8 whole to the power minus 2. So we can change in this power into plus form, or we can write 64 upon 121. Hope this one is easier for you. Move to the next type of question. Now our next question is, so this is a question how we solve this one. Remember, we must follow the BODMAS as well as laws of exponent. So how we solve this one? See first this side. Here we have same base minus 1 upon 3 minus 1 upon 3 minus 1 upon 3 minus 1 upon 3. So here we can write down minus 1 upon 3 whole to the power 8. Divide side is there, so power must be subtracted, minus, in this case we can say minus 1 upon 3 5 minus 3. In this case we can say minus 1 upon 3 whole to the power 3 minus 1 upon 3 whole to the power 2. Now we are going to simplify the powers. Here negative base is there, an odd power, so answer must be negative 1 upon minus 1 upon 27 minus, here minus base but even power, so it's a 1 upon 9, so minus plus it's a minus. So ultimately what we can do, see this side, no, ultimately, or we can, I'm going to rub this board so that you can easily understand. So this is your this is your last solution. Here we have to find out the LCM. It's a 27, so minus 1 minus 9 threes are, so it's a minus 3. Ultimately what we have, minus 4 upon 27. Hope this one is clear to you. All of you try to solve exercise 4C by yourself, and remember 4D and 4E is not in your syllabus, that is excluded one. That's all for today. Thank you.